Good morning, dear students. So, welcome to the maths class for today. Today, we are going to understand a new topic, which is altogether a new topic for you guys. That is exponents. So, let me start with the number. Till now, you have learned so many times squares, square, like if we have square of 4, it is 16. So, what is this term square of 4? What is square? Square is this number which is here, if you talk about square of 4 becomes exponents. So this is the base and this is the power, or we call it as exponent. Okay. So this is the basically exponent about which we are going to study in this chapter. So what does this 4 square of 4 means? That we have to multiply this 4 2 times. Okay, this does not mean that you have to multiply 4 into 2. No, this is wrong. This means that you have to multiply 4 2 times. What does it imply? Whatever the power is there on the number, we have to multiply the number up to that value of power. Like, if I like 2 or 5, so we have to multiply 5 3 times. Okay, here this is your base. You can make it remember like the number which is written down is base. Base is down. So the number which is written at the downside, that is base. And the number which is written at the upper side, is the base. Okay. And exponent shows that you have to multiply the base up to that. Okay. So if I talk about, let's say, if we have 8, so we like 8, multiply 8, multiply 8, multiply 8. Okay. Now, understand what does this forms. This is called, this form is called exponential form. This is called exponential form or notation. Exponential form or exponential notation. So sometimes you get questions like, so for example, if there is a question x into x into x into a into b, and you have to write this expression into exponential notation. How will you write? So there are two variables, x and a. X is how many times? 1, 2 and 3. So the power will be 3. And a is how many times? So power will be 2. And these both terms are getting multiplied. So you will put multiply and so this is the exponential notation of this expression. Okay. Now, and what does this form called? This is called expanded form. Expanded form of exponential notation. So here is questions in a vice versa form. For example, this sounds like this, and we have to write in expanded form. So that means we have to write 3 4 terms and q 2. Okay. So this is your exponential notation and this is a expanded form. So the question may come in this form or this form, and will be asked to write in opposite form. Right? If question comes in standard form, we may be asked to write in exponential notation. Or if question will come in exponential notation, we have to write in expanded form. And also, if you look at exercise 5A, the first question is like this only, you have to write the question in exponential notation. So I hope this is clear what is exponential notation, what is standard form. Next is, if the question comes that elaborate or evaluate the value of the power of earth. Evaluate or find the value of this expression. What will you do with the value of 500? Then what will you do? 2 are 4, 2 are 8, 2 are 16, 2 are. So the answer of 2 to the power 5 is 30. So whenever the question comes, find the value of 5 to the power 3 or 4 to the power 2, write the number and expand the form and then simply multiply. Now here, the main point where the children make mistakes, they have some skill. Without multiplying, they write 4 multiplied by 4, 8. Because like that 4 to the power 2, 8, this is 8. Don't do this mistake every time. Whenever the question comes in exponential notation, just multiply it in expanded form, then multiply. Okay? Then If the question is in the vice versa form, like say 64, and you have to write an exponential notation, what you have to do, just start taking the LCM of the prime factors. Here, this is very important. Prime factors. Always take the LCM of any number using prime factors to write out that number in exponential notation. So start taking the LCM into this. Then it is 16, then to 8, then to 4, again to 2, to 1. So this is the LCM. Now you can see all the factors are only 2. How many groups are there? 1, 2, 3, 4, 5, 6. So we can write 64 in the form of exponents like this to the power 6. So this will clear the topic again. I will explain to you again. Till now you just this concept how to write any number in exponential notation or expanded form.
We will understand how to give any number like 81, let's say, how to give exponential notation form to this number. So very first step is you have to take the LCM, but while taking LCM you should keep in mind that always start taking LCM with prime factors. Do not take composite numbers, always take prime factors to take the LCM. So you know that this number is not divided by 2, so let's start with 3. It is 27, then again 3, 9, again 3, 3, again 3, 1. Okay, so this shows that the factors of 81 is 4 times 3. 3 multiply 3 multiply 3 multiply 3. And as you know that how we can give the exponential form to this expression is 3 to the power 4. So if you want to give the exponential notation form to the 81, so we can directly write 81 is equals to 3 to the power 4. And if you want to see whether it is correct or not, you can expand it and multiply to check whether again you are getting 81 or not. Okay, now let's take another example. Let's take another example, say 72. Okay, so again you know that this can be divided by 2. So start taking the LCM with 2. It is 36, then 18, then 9. Now what children do mistakes generally, they directly write 9 here. But as I told you that you have to take LCM with prime factors. So you have to write 3 because 3 is the prime factor, prime number, but 9 is not the prime number. So this is the way we will take the LCM of 72. Now write all the factors. It is 2 multiply 2 multiply 2 multiply 3 and 3. And now you very well know that how you can give the exponential form to this expression. It is 2 multiply 2 ki power 3 multiply 3 ki power 2. So directly if you want to write the exponential form of 72, it is 2 to the power 3 multiply 3 to the power 2. So these are the simple numbers. Now let's take another example where you need to write any fraction in exponential notation. So let's take it's 8 upon 27. Okay. So start taking LCM of both the numbers separately. Do not take LCM together. Take the LCM separately. LCM of 8 will be, this, and LCM of 27 will be this. So 8 upon 27 is equals to 2 multiply 2 multiply 2 upon 3 multiply 3 multiply 3. So answer will be 2 upon 3 ki whole power 3. Okay, so this way you can write the fraction in exponential notation. Every time keep this in mind, whatever the numerator is or denominator is, you have to take the LCM of both the numbers differently, not individually, not together, and then write it in exponential notation. Okay, sometimes what will happen, you will get the number where you will not get the same factors. So it will be 81 upon 64. Okay, so 81 as you have taken the LCM. Now 64, 32, 16, 8, 4. Again this number has the same factors, but here 3 is 1, 2, 3, 4, and here 2 is 1, 2, 3, 4, 5, 6. So 81 will be equal to 3 to the power 4 and 64 will be 2 to the power 6. So don't get confused that it is not correct, it is the right form, because the factors of both the numbers are in different numbers. So that is okay. Okay, but keep this in mind that numerator and denominator's LCM should be different. Then this way you can do the exercise 5A, and there are some laws of exponents also. I hope you all have understood for how to write any number in exponential form, or vice versa, how to write in any number in a standard form, in a simplest form. Now the next topic which we are going to learn today is laws of exponents. So there are some laws which are applicable for exponents. Laws means rules, right? So sometimes what happens is you get some questions, and which we can do with the help of these laws. Let's learn what are these laws and how you can identify which law is applicable on which portion, which question. So very first law says, if there is a number a raised to the power n, multiply a raised to the power n, it gives a raised to the power n plus n. This shows that if the base of both the numbers are same and powers are different, and also they both are multiplying with each other, so we have to write base once and we have to add the powers. So for example, if the question is 1 power 4 की power 2 multiply 1 by 4 की power 5. So instead of writing it 2 times, it 5 times and then multiplying, instead of doing that, you can do simply, you can see that the base of both the numbers are same and powers are different. You can write base only one time and add the power. So simply you will get the answer as 1 by 4 and power is 7. Okay, so whenever the base is same, power is different, and both the numbers are multiplying, you have to add the powers. And if the numbers are dividing, then you have subtract the powers. You have to just keep in mind, multiply with plus, divide with minus. So if the numbers are dividing, you have to do the minus. And also keep this in mind, if m is greater than n, so you will do m minus n, and if n is greater than m, then you have to do n minus m. For example, if it is 4 to the power 7 divide 4 to the power 2, so you can directly write 4 7 minus 2, because these numbers are dividing each other, so answer will be 4 to the power 5. So whenever the multiply will come, you will add, whenever divide will come, you will subtract. Now next law says that if single number has two powers, simply multiply the powers, don't add, multiply. If the single number has two powers, so say 1 by 2 की power 3 and then whole power 2. So what does children do? What do children do? They do 1 upon 2 to the power 5, which is wrong, because if a single number has two powers, we have to do the multiplication of the powers. That means 3 multiplied 2 is 6. This is wrong, this is correct. Always keep in mind, when a single number has two powers, you have to do multiplication of powers, not the addition. Okay, next law says, here we studied that the base is same and powers are different. Next law says, here the powers are same but the numbers are different, the bases are different. So what you have to do, here we were adding the powers, you have to write power one time here and you just multiply the numbers. So let's say an example, 2 to the power 4 multiply 3 to the power 4. So here powers are same, bases are different. You directly write 2 multiply 3 की power 4, which is 2 3s are 6 to the power 4. Okay, and this is very easy and important law, that if any power has the any base has the power 0, simply it implies 1. Anywhere, if anywhere any big number has, let's say 1000, 1 to the power 0, simply in place of this whole number you will directly write 1, nothing else. Okay, then the last law is here written. It says, if any number has power as negative, see, any number has negative power, so by just make the reciprocally doing the reciprocal of that number, you can make the power plus. So for example, if if the number is 4 to the power minus 3, what you have to do, just take the reciprocal of the number and the power will become plus 3. Okay. One more example. So if it is 2 upon 5 ki power minus 3, so what you will do, just do the reciprocal, it will be 5 by 2 ki power 3. Okay, so these are the 7 laws which are important for your exponents chapter. Again, we will revise. If the bases are same, powers are different, and they are multiplying each other, we have to add the powers. If the bases are same, powers are different, and they are dividing, then we have to subtract the numbers by just checking which number is greater. Okay, m or n. Next is, if a single number has two powers, you have to multiply the powers. If the bases are different, powers are same, you have to multiply the bases. If any number carries the 0 as power, you will write simply 1 there, nothing else. And the last law says, if any power has negative, if any base has negative power, so to make the power positive, you just take the reciprocal. This way, I think you all have understood the laws of exponents. After this video, I will be sharing a worksheet related to this topic only. Just try those questions. If you have any doubt, kindly share with your maths teacher. Thank you and have a nice day.